sec, have a look up here. Piecewise functions, most real world functions are, I don't know about most, this is a claim I can't support, but a lot of real world functions are not things that you can describe with a single equation, right? Like you graph all these functions like this and parabolas and all kinds of different things and straight lines, but often things work where a function will match something for a piece of it, but not the whole thing. If one example I'll give you is if we drew a graph of someone who was skydiving, they jump out of the plane, they fall for a while, they open their parachute, and they land on the ground. If we graphed time and we graphed the distance they have fallen, so at 0 here, they're jumping out of the plane. They're going to obviously start to fall faster and faster, right? So it ramps up, right? The slope of that thing curves up, right? I know in grade 10 you learned slopes have to be of straight lines, but we're going to talk about slopes of curves, right? It's steeper here than there, right? Which makes sense because the person is falling faster and faster. But at some point, the wind resistance balances it out, and they reach what's called their terminal velocity, and they will fall at they'll be going as fast as they can go, right? They're not going to keep getting faster and faster. So then it's going to straighten out. So if you wanted to graph those two things, you'd have to put one equation for that part of it, like a quadratic function of some sort, right? I don't know, ax squared, whatever the a is, who knows. But it would be up to, let's say it takes, I don't know how long it takes to, I know nothing about skydiving, but let's say it takes 5 seconds to get to your terminal velocity. So then this would be between 0 and time. I guess I should use t for time. Between 0 and 5. And then after that, it would be some straight line function. I don't know. Let's call it m times t plus, who knows, some y-intercept. Whatever it is, I don't want to bother figuring it out. But that would be the equation that applies for this piece in here, right? But that would be between 5 and whenever the next piece ends. At some point, they're going to pull their parachute, and then what's going to happen to that? What's going to happen to the rate they're falling? It's going to slow down. Does it mean it's going to go this way? That would be pretty cool because it would start going back up in the air, right? Less distance, getting closer to the plane. But it's going to be a shallower slope, but it's still going to increase, right? The distance they've fallen is still going to increase. So you'd need another piece for this, I don't know, maybe 10 seconds or something, even though the scale doesn't work there. So you might have, be for that part, and then it's something else here. C times t plus d, who knows? Whatever that is, whatever that other line up there is, when t is greater than or equal to 10. Don't worry about all this. I just don't want to bother making up numbers for these, all these a's and b's and everything like that. But you say y is equal to all this stuff. It's equal to this function for this interval, this function for this interval, and this function for this interval. Okay? You could write a piecewise function for the energy level of the average grade 12 over the year. If this is 0 and this is the end of the year after 10 months. So 0 starting in September, where's our energy level? It's pretty good at the beginning of the year. Come on, you guys, let's be honest here. It's not too bad, is it? Well, what? Like, I don't even know how we're measuring energy level, but whatever. Let's say there's some starting value. How long can you maintain that? Does it stay constant? You think it goes down right away? Oh, okay, you got to build. So you think it goes up for a bit here, but then it plateaus, and then what happens? I would say somewhere in the middle here, about the 4th or 5th month towards Christmas. Actually, maybe there's a couple little, I don't know, getting too complicated here, but plateaus, goes down. Maybe Christmas comes and you're slightly re-energized, and up here a bit then, and it starts to go downhill here, but then as we get close to the end of the year, doesn't it kind of ramp up again? I think I didn't go down enough here. It's probably like this. Back up, I don't know. Whatever. You would have to give, unless you could come up with a single function that matches all that, and you might be able to come up with some trig function that roughly approximates that, you'd have to do it in pieces, or you could do it in pieces, right? You could say, for this part, it's one thing. For that part, maybe it's another thing. Anyways, that's what piecewise functions are. The one that, I don't know why I didn't put the horizontal axis here. But when you draw the thing, you draw each chunk of it, and it isn't always that they're going to match up, or going to join each other. I made that one up so that it did join each other. So when you draw it, you should find that. So there's the horizontal axis. The first part of it there, negative x, but only when x is less than 0. So negative x is, this is negative x, right? That line. But we only want the part for when x is 0, so we don't want this part of it. You only want that part, right down to here. Can we stop talking, please? I know the desks being together is going to cause a problem, but I think we can do this, okay? I'm not going to talk for hours and hours. In fact, I'm timing myself up here, right? So the second part of it here, x squared, we need the part of x squared. Again, the graph of x squared looks something like, you could use some reference points here for yourself maybe. It looks like this, but we don't want all of this, right? We want just that part that's over here. You only want the part that's between 0 and 2, so you want this chunk of it right there. And then after that it says 4. 4 might not seem like it's a function. It's a constant function that doesn't change. If something's equal to 4, O is equal to 4 there like that. And you could put an arrow on each end to say it keeps going. I made that one up so that it's continuous, as in it's joined here. But you could have it where this part wasn't joined to that. Now it's a little bit complicated to say whether it's a continuous function or not. We're going to get to that eventually, but for now let's just keep it simple. And that thing's joined. The one down here is not joined together, but you can still write it as 3 pieces. Maybe in a few minutes we'll put the equation up here for this to give you a chance to do that. Or has everybody tried to write an equation for that? Y equals something. You're going to have 3 pieces. Maybe it helps first to identify the intervals. Like the first one is x is less than 1, right, for this part of it. Okay, less than 1. But you need the equation of the line. And in this part you might, you can either think, well, what would the y-intercept be if you want to do it in that form? Or you could use point slope form. I'm going to pause this while you try and write the equation. All right. Okay, if you can refocus up here, check the equation. The first part of it there, the equation of that is negative x plus 1 or 1 minus x if you want to write it more simply. When x is less than 1, the center part is a constant function at 4, right? A constant function is it doesn't ever change, same amount, okay? And the last part is if you want, I suppose you could, I think it's easiest to do this with point slope form, right? The slope is 3, so it would be like 3x, except you have to use the as though you're shifting it to that point. Y plus 4 and x minus 5 gets that point, right? If you multiply this out, then of course, if you want it in the other form, you can do this. 3x minus 19. X is greater than or equal to 5. That's the equation I would write. Okay, are we good? Let's try not to make mistakes on these kinds of things. I know we all make mistakes, but just look carefully at that, whether it's equal to or not. Technically, it can't be both functions. Like, even though they're the same value, well, actually, for this one, they're not. Even if they were the same value, you got to decide which function is going to apply at 1, say. Okay. In this case, this function applies at 1. That's why this is less than or equal to there, greater than or equal to that. Anyways, let's move on to the next section here.